Okay, let's begin the class. So it's about Markovnikov rule. So Markovnikov rule is about the addition reaction, electrophilic addition reaction of hydrohalogens. Okay, HCl, HBr are unsymmetrical reagents to the olefin to result into the products. Okay, so when it is unsymmetrical, okay, where olefin cannot be similar from the both sides, then it can be applicable. Okay, the first part. So basic rule of the Markovnikov is olefin should be unsymmetrical. Okay, olefin should be unsymmetrical, and reagent must be unsymmetrical. Okay, then it is going to applicable. So rule is that more substituted carbon, okay, more substituted carbon will be going to added with the negative, and less substituted carbon will be going to added with positive. Okay, so for this the product will be this one. Okay, so this is what Markovnikov. So first question, Markovnikov rule is not applicable, so it is going to applicable for only unsymmetrical. So among A, B, C and D, so which is not applicable? Screen కనిపిస్తుందా? If screen and voice is everything okay, you can give the response also. స్క్రీన్ వాయిస్ అన్ని కరెక్ట్ ఉంటే మీరు రెస్పాన్స్ ఇవ్వచ్చు. ఓకే, జలంధర్, are you there? Okay, so applicability of Markovnikov among A, B, C, D. So A is symmetrical or unsymmetrical? So B is also symmetrical, C is also symmetrical. What is meant by symmetrical means you can find both the sides of the olefin similar. Okay, so D is also symmetrical, so it is not applicable for dissolve. Okay, next, here is the question, HBr readily reacts with. So when a reagent is going to attach to the double bond, okay, let's say it is a double bond, so initially H plus will be abstracted, that's why it is called electrophilic addition reaction, so that carbocation will generate. Okay, so reactivity is the question, so it will be stability of the carbocation. So among all these, which is going to give the stable carbocation? If it is A, it is going to give CH2 plus and the CH3, because other side of the CH2, H plus will be going to attack. If this is there, double bond will be attacked, so positive charge will be generated here. Okay, if this is there, double bond will be attacked, so positive charge will be here. Okay, if this is there, positive charge will be here. Now tell me, which is the most stable carbocation? This one. So option B is more giving tertiary carbocation. This is secondary. This is secondary. This is primary. So tertiary is more stable carbocation, so that the reaction will drive towards the tertiary carbocation fast. So reactivity will be high. Okay, this is the answer. Next, which of the following alkene is more reactive? So in electrophilic addition, when it needs to attack on the electrophile, the olefin must act as a nucleophile. Okay, olefin must act as a nucleophile. The more is the nucleophilicity of the olefin, the more will be the reactivity. Okay, So for nucleophilicity it must be electron rich. Okay. సో ఎలక్ట్రాన్ రిచ్ ఉండాలి. సో డబుల్ బాండ్కి ఎక్కువ సబ్స్టిట్యూషన్స్ ఉంటాయి. ఓకే, ఎక్కువ ఎలక్ట్రాన్ రిచ్ ఉంటుంది బికాజ్ దీస్ ఆల్ ఆర్ ప్లస్ సైకిల్. ఓకే, సో రియాక్టివిటీ ఎప్పుడు ఎక్కువ న్యూక్లియోఫిలిసిటీ ఉంటే ఎక్కువ రియాక్టివిటీ ఉంటుంది. సో మోర్ న్యూక్లియోఫిలిసిటీ విల్ బి విత్ B. Okay, because these are two plus tables, this is one plus table, this is zero plus table, this is with three plus table. Okay, so this is more reactive. Okay, so these are the based on the reagent system and electrophilic addition reaction. Now we need to give the products of the Markonikov. So these are very important. So I hope you are very attentive. So initially what happens? H plus will be abstracted. So if it is H plus abstracted here, positive ion will be generated here. If this in other way, positive ion will be here. So among these two, which is more stable? This is primary, this is secondary. So which is more stable? Okay, so secondary is more stable. So reaction will direct towards it. So now Br minus will attack on this. This is here. Okay. So major product will be this one. Okay. So IUPAC name would address. Okay. So our secondary product form primary product form and would address. So be careful with it. Okay. Is it okay? Just a minute. Here is a mistake. So after formation of secondary, ఏదైనా డౌట్ ఉంటే అడగండి. ఓకే, సో సైలెంట్ ఉండాల్సిన పని లేదు, మీకు ఏ డౌట్ ఉందో అడగండి. After formation of secondary, there is a rearrangement 1,2 hydride shift. Okay, 1,2 hydride shift is going to happen. Okay, so it can be possible with tertiary. Okay, so carbocation stability, always rearrangement is going to happen so that stable or best possibility are always tertiary carbocation leading will be happen. Okay, so carbocation once generate అయినాక హైడ్రైడ్ షిఫ్ట్ కానీ మీథైల్ షిఫ్ట్ కానీ జరుగుతుంది, రీఅరేంజ్మెంట్ జరుగుతుంది. జరిగి ఎప్పుడైతే టెర్షరీ కార్బోకేటైన్ పాసిబిలిటీ ఉంటుందో, ఓకే, ఎప్పుడు పాసిబిలిటీ ఉంటుందంటే ఈ 1,2 హైడ్రోజన్ షిఫ్ట్ ఎప్పుడైతే 1,2 పొజిషన్స్లో ఉంటాయి కార్బోకేటైన్ అండ్ హైడ్రోజన్, ఆర్ 1,2 మీథైల్ షిఫ్ట్ ఆర్ 1,2 alkyl shift, if they are at 1,2 position only, it's going to happen. If that is going to happen, it will lead to the most stable carbocation. Okay, so if it is most stable carbocation, tertiary will be the most stable carbocation among this system. So that will be going to add up with the Br minus. So final product will be this. Okay, take the screenshot or you can write also, or if you need repetition just ask for me. Okay, so I can repeat. అర్థం కాకపోతే అడగండి, రిపీట్ చేస్తా. అర్థమైతే నెక్స్ట్ క్వశ్చన్కి వెళ్తాం. విజయ్ అర్థమవుతుందా? యా యా చెప్పు, రిపీట్ చేయాలా? వినిపిస్తుంది, చెప్పు, వినిపిస్తుంది. ఓకే ఓకే సిద్ధు, ఐ రిపీట్. సో ఏం లేదు, ఫస్ట్ reaction initiation will be with the nucleophile, that is olefin. It will abstract the H plus. Okay, once it abstracts the H plus, there is a possibility of carbocation generation is here and possibility of carbocation generation at here. Okay, Why carbocation generating? Because it is abstracting the H plus by donation of its lone pair. Okay. సో ఇది ఇచ్చేసింది కనుక ఈ పై ఎలక్ట్రాన్స్ ఏవైతే ఉన్నాయో అవి దీనికి ఇచ్చేసింది. సో దీని మీద కానీ పాజిటివ్ ఛార్జ్ రావాలి. ఓకే. సో అమాంగ్ దీస్ టూ, this is primary, this is secondary. Secondary is more stable. So this will move towards the next step. Okay. So in secondary also there is a possibility of hydride shift, so that it will be going to form tertiary and hydrogen will be here. Okay. This is called 1,2 hydride shift. Hydride means it is negative, H minus. Why H minus? Because it is moving along with its bond. Okay, bond ని తీసుకొని వెళ్ళిపోతుంది. సో అందుకని ఇక్కడ పాజిటివ్ ఛార్జ్ వచ్చాయి. ఓకే. సో దిస్ ఇస్ కాల్డ్ 1,2 hydride shift. So in carbocation stability, 1,2 hydride shift and 1,2 methyl shift are very common. Even alkyl shifts also very common. So final carbocation will be, okay, final carbocation will be most stable carbocation. Whatever may be the shifts, final will be most stable. Okay. So based on that, this is the most stable carbocation which is tertiary. Now it will be going to conclude the reaction with product formation. So Br minus will attack here. Okay. So final product, that is major product, will be 2-methyl 2-bromo-butane. Okay, 2-methyl 2-bromo-butane. Okay. So now write the product for this. So రాయండి, నేను ఆప్షన్స్ కూడా ఇస్తా. ఆప్షన్ ఏ 2,2-dimethyl 3-bromo 2,2-dimethyl butane. Option B 2,3-dimethyl 3-bromo 2-bromo 2,3-dimethyl butane. Option C 2-bromo 3,3-dimethyl butane. Option D 3-bromo 2,3-dimethyl butane. సో ఈ నాలుగిటికి స్ట్రక్చర్లు రాసి అంత అయిన తర్వాత దీని నుంచి ఏమొస్తాయని చూసేసండి. ఫస్ట్ దీన్ని ప్రొడక్ట్కి కన్వర్ట్ చేసి ఆ ప్రొడక్ట్కి యూపీఏకి నేమ్ రాసి ఇందులో ఏది మ్యాచ్ అయితే అనేది చూస్తే తొందరగా. So what could be the answer? పెన్ను పేపర్ పక్కకు పెట్టుకున్నారా? ఆప్షన్ ఏ doing this. అంతేనా? జలంధర్ ఇదేనా? దిస్ ఇస్ రాంగ్. ఇంకా ఇంకేమైనా పాసిబిలిటీస్? సో మెకానిజం రాసి చూడాల్సిందే. ఓకే, మెకానిజం రాస్తే మీకు అర్థమవుతుంది. సో హెచ్ ప్లస్ ఫస్ట్. సో ఏమైంది? సో ఇక్కడ పాసిబిలిటీ ఉంది, ఇక్కడ పాసిబిలిటీ. ఓకే, హియర్ ఇస్ ద టూ పాసిబిలిటీస్, ప్రైమరీ, సెకండరీ. సో విల్ automatically consider secondary because it is more stable. Okay, so this is fine. Once it got converted into secondary, there is a 1,2 methyl shift possibility. This is 1, this is 2. So 1,2 methyl shift possibility. Once it gets converted into shifting, so here is the methyl. So here is the carbocation. So the driving force, it is secondary. Once it got formed, tertiary. If it is methyl shift is happen and the same secondary is going to result, that methyl shift will not valid. Okay. సో ఎప్పుడైతే హైడ్రైడ్ షిఫ్ట్ మీథైల్ షిఫ్ట్ జరిగినాక కూడా అంతకు మించిన స్టెబిలిటీ గెయిన్ చేయకపోతే అటువంటి రీఅరేంజ్మెంట్స్ కానీ షిఫ్టింగ్ కానీ జరగదు అన్నట్టు. జరిగినా మళ్ళీ రివర్స్ బ్యాక్ వస్తుంది, ఎందుకంటే స్టేబుల్ కార్బోకాటైన్ ఇస్ ద మెయిన్ మోటో ఫర్ ది రీఅరేంజ్మెంట్. ఓకే, సో ఇది పాసిబుల్ అవుతుంది, ఎందుకు అంటే దిస్ ఇస్ టెర్షరీ. ఓకే, ఆల్వేస్ కార్బోకాటైన్ విల్ లీడ్స్ టు ది మోస్ట్ స్టేబుల్ form. Okay, so this is the tertiary most stable one. Now is going to add it up with the Br minus. So product will be this one. Okay, this is the final product. So you need to convert again and again with the hydride shifts and methyl shifts. Okay, so here all are methyl, so there is no hydrogen, so hydrogen shift will not be possible, only methyl shifts are possible. The resulting product will be this. Okay, so its name is 2,3 dimethyl and this is bromo. So 2 bromo 2,3 dimethyl butane. Option B is correct. సో ఇటువంటి క్వశ్చన్లే మీకు ఎగ్జామ్లో అడుగుతారు. ఓకే, సింపుల్ క్వశ్చన్ అడగచ్చు, బట్ ఇటువంటి మీ ర్యాంక్ని డిసైడ్ చేస్తాయి. Is it clear or shall I repeat? రెస్ట్ ఆల్ మిగతా వాళ్ళు next question. So 6th one. So here I am giving the options. Option A, option B. So which is the major product of this reaction? ఇది కనిపిస్తుంది కదా 6th, or shall I make it larger? So 6th question we are discussing. Okay. So what could be the product? Here I am giving the options. Okay, give the answer. So here I can see 7 students. ఆరుగురున్నారు. Isha, Durga, Jalandhar, Diva, and some more. So చెప్పండి మీ ఆప్షన్ చెప్పండి. Yeah, it got yes. One carbon less than. Hmm. ఇక్కడ కూడా రాదు, ఇది ఇక్కడ వస్తుంది. వేరే ఇక్కడ రాదు. సో ఈజ్ ఇట్ బి? ఇదే మ్యాచ్ అయిందా? So initially H plus will attack with which double bond? So nucleophilicity of the double bond, if it is more, it will be going to attack. So when consider these two double bonds, and there are double bond inside the ring. Okay. So there are 5 competitive double bonds. Okay. Among all these, the ring double bonds will be less nucleophilic because they are involved in the resonance. Okay. Involved in the resonance. Okay. So comparatively, this double bond and this double bond will less resonated, less conjugated. Okay. So if you consider this double bond, it is attached to the minus I group, which is phenyl. Okay, and one olefin. Okay, this is also minus I. When you consider the double bond of this, it is attached to no plus I or minus I group. This is one minus I group. Okay. So when minus I groups are attached with the olefin, it's going to decrease the electron density. Okay. So the terminal double bond which you consider will be more nucleophilic. Always terminal double bonds with more nucleophilicity. The more is the nucleophilicity, H plus attacking tendency will be more. So resulting into the attack of the H plus. So it may give carbocation on this, it may give carbocation on this. So if this is there, this is primary carbocation. If this is there, this is allyl carbocation, which is more stable. So this is eliminated. Okay. After this, it may conjugate. Okay, it may resonance. Okay, మీరు నేర్చుకున్న ఇండక్టివ్ ఎఫెక్ట్ మెజోమరిక్ ఎఫెక్ట్ ఇట్లా యూజ్ అవుతాయి అన్నట్టు. ఓకే, సో విత్ ది కాంజుగేషన్ may convert the double bond here and carbocation here. Now this is benzyl and this is allyl, which is most stable carbocation among all these. Okay, so this is simple allyl. Okay, this is benzyl as well as the allyl system. ఇటు నుంచి చూస్తే ఇది allyl. Okay, ఇటు నుంచి చూస్తే benzyl carbon. So double stability. So this is the major carbocation that's going to available in the reaction system. Now whatever the HBr, Br minus will attack on this. So final product will be this one. Okay, so option B. You need to see the nucleophilicity of the double bonds. Okay, and you need to see the carbocation stability. That is the major theme of these reactions. Is it understood or shall I repeat? Okay, I'll go to the next question. So similar question number 7. What could be the product? Uh, so A or B, which is the major product? So this is HCl. Here, because upon carbocation generation, the benzyl will be more stable. Benzyl carbocation will be more stable, so that it will be attacked. So this is major. Okay. Next, this one. So here I am writing the possibilities. Here, here. This is B. This is C. D is none, which is the major product. So which is the major product? మొబైల్ డేటా ఉందా అయిపోయిందా B. Perfect. Because once it gets attached with the H plus, carbocation may generate here or may generate here. This is benzyl carbocation which is more stable, so it will continue for further. So bromine is going to attack here. Okay, so B is major. Data ఉందా అయిపోయిందా మీది okay, let's continue for the next question. So if this is the case, so what could be the major product? So option A. can be see why. Okay, పాజిటివ్ వస్తుంది. ఓకే, కరెక్ట్గానే ఇక్కడ పాజిటివ్ వస్తే ఇది స్టేబులా, ఆర్ ఇక్కడ పాజిటివ్ వస్తే ఇది స్టేబులా? సో here both are benzyl systems. Okay, both are benzyl systems. Okay, so both will be in the resonance, but this is with electron donating group, which is electron excess, which will donate the electron density more towards the carbocation. So electron donating side will be the most stable carbocation, so D will be the major force. Okay, so this is phenyl ring, which is with plus I group, will be more stable. Okay, so phenyl ring which is with minus I groups or minus M group will be less stable, so that side carbocation will not be generated. Okay, so similar type next question. 10th. So I think I should not write it. So this can be written as pi. Okay, so this is pi. Okay, this is can be written as phenyl shortcuts. Okay, so pi OCH. Yeah. Okay, option A, option B, option C, and D. So which is correct option? D. Right? So do you think phenyl is going to stabilize more than the anisole ring? ఇది ప్లస్ ఐ గ్రూపా మైనస్ ఐ గ్రూపా? OCH3. Is it a plus I group or minus I group? This is minus I group. Okay, so it will stabilize, but the thing is it is plus M group. Okay, plus M group. So electron donation will happen. Okay, so it will stabilize more when it's forming carbocation. Okay, so minus I groups ఉంటే stability తగ్గుతుంది. Okay, but ఇది minus I తో పాటు plus M group, so stability increase అవుతుంది. Okay, so this is going to stabilize more, so option A is correct. Okay, so next one, if it is NO2, so this is withdrawing, this is donating, okay, comparatively. So positive ion will be generated here, chlorine will be forming here, okay. So among these two, this is donating, okay, and this is minus side group, okay, this is plus side. But this is plesium group, which is more effective donation when compared to inductive effect. So Br will be going to form here, okay. Hmm. Now if this is the case, okay, so once positive ion can be generated here, positive ion can be generated here. If positive ion is here, it will be benzylic, okay, benzylic. So chlorine will be going to add here, okay. This is the final product, okay. Now withdrawing group is this side, so carbocation will generate this side. So final product will be. So any doubts you can ask also, okay. Same withdrawing group is here, so positive charge will be generated here, so Cl will be added here, okay. Next also same withdrawing group, so bromine will add here, okay. Now this one. So here this is also a strong withdrawing group. So if a positive ion generates, it will be destabilized. So positive ion will generate for terminal carbon. So the product will be this one. Okay. So this is called alpha. This is beta. Always beta position is going to form carbocation. Alpha position is going to form carbene ion of the conjugated aldehydes. Okay. This is conjugated aldehydes. So if it is anion generated at the alpha position, it will be stabilized with the withdrawing group. If cation is going to generate, it should be at beta position. Okay. Similarly, here beta position. This is alpha. This is beta. So beta position is going to attach with the bromine. Okay. So similar beta position. Okay. So this is also similar beta position. Okay. So this is also C double bond OH. Similarly, beta position. Okay. So this is here. So here is a chance of replacing the OH, or that is what, C double bond OH with the HCl. H and Cl will be going to eliminate. Cl minus is going to attack. So there is a combination of products from the this kind of starting material. COCl is going to happen. Okay, carbonyl chloride. This is also a possibility. Okay, so sometimes it may ask. Okay, so for esters also there is a possibility of hydrolysis, and there is a possibility of bromine attack at the beta position. Okay, amides also possibility of hydrolysis if it is under water. If it is under water. Okay. So hydrolysis as well as the bromine addition at a beta position. Bromine, of course, it will be go to beta position only. Okay. Next, trichloromethane. This is also withdrawing group. So carbocation will generate here, bromine will attack here. Okay. So here it is minus I. Okay. This is little bit important. So look at this. So carbocation if it is generated here, it is minus I but plesium. Comparatively, if I given the two carbocations, which is more stable. So mesomeric effect involved will be more stable. So this will be more stable. So product will be with this only. Okay. We have seen this example in the inductive effect and mesomeric effect. So the same is going to repeat. Okay. So this is the final product, major product. Okay. So if this is there, there is no conjugation, so there is no mesomeric effect, only withdrawing nature. So this side withdrawing, this side donating. So it will be more stable. So carbocation will generate here, and not only the donating way, it is having three hyperconjugation structure. This is having two hyperconjugation structure. So this is more stable. So it will be going to attach with the bromine. Okay. So all basics and all electronic displacement effects are involved in this reaction. Okay. Now, if a carbocation generates here, it becomes primary. If a carbocation generates here, it becomes tertiary. So tertiary carbocation will be going to lead the product. Okay. This one. So if a carbocation generates here, it will be primary. If a carbocation generates here, it will be tertiary. So at tertiary. Look at this. Even if it is starting material is different, okay. Even if it is starting material is different in these two, the kind of addition and the kind of products are same. Okay. So it just depends on the stability of carbocation, not the how the starting material and what could be the starting material. Okay. Now also you can see. So there is a possibility of carbocation, there is a possibility of carbocation. So if this is there, it is a secondary. If this is also there, it is a secondary. Once this secondary carbocation is generated, okay, so it will be 1 to hydride shift so that tertiary carbocation will be forming. Okay, so this going to lead into the product. So final product will be Cl. Again, whatever may be the system, again the product has given the same. Okay, let's say if it is this carbocation, H plus hydride transfer will happen here. So carbocation will generate here. Again hydride transfer will happen here. So carbocation generates here. Because all are secondary, there is a possibility of hydride transfer. Again. So lastly the hydride transfer which will give the tertiary carbocation, that will be the final. Okay. So you need to be careful with the carbocation system. So always best stability. Okay. Always best carbocation will result into the product. Okay. So these are little bit important. So hold some grip on the carbocation stability. There are some other examples. So if this is the case, initially carbocation will generate here and will also generate here. So accordingly, this will be more stable. So this could be the tertiary. Okay. So tertiary, if at all hydrogen transfer from the one to hydrogen shift, it is also going to give carbocation. Okay. So among these two, which will be the most stable? This is one and this is two. So which is more stable? Yeah, because it is more bulky group. Okay. But if you can see with the hyperconjugation, this is two hydrogens, this is one hydrogen, this is two hydrogens, two hydrogens. So total five hyperconjugations. If this is the case, this is three hydrogens, this is three hydrogens, and this is one hydrogen. So total seven hydrogens. Now tell me which is more stable? సో ఇటువంటి మిస్టేక్లే మనం చేయొద్దు అన్నట్టు. ఓకే. సో keen observation should be there, and when you are finding the most stable carbocation, you must see the inductive effect, measurement effect, and hyperconjugation. Okay. So you must see him hyperconjugation, inductive effect, and measurement effect. Then only you decide whether it is a stable carbocation or not. Okay. So out of these two, this will be the stable. So bromine will be going to add here. So this is the major product. I think this is repeated in HC, I think. Okay, HC previous question. So be careful with the examples like this. Put a star mark also. Okay. Next, HCl addition. So there is a possibility of carbocation generation here and here. So this is more stable. So Cl will be going to add here. Okay. 3-chloro cyclohexanol. Okay. So if this is the case, carbocation will be generating here, which is more stable, tertiary. So final product will be okay. If this is the case, this is one more important one. Okay. So initially carbocation will generate here and here. So this is tertiary, which is more stable. Okay. But it is a strain ring. So it can go expansion. Okay. It can go expansion from the carbocation of this. Okay. This is going to form first. Okay. It can go expansion. Ring expansion must happen so that stability of the complete molecule is going to improve. Okay. Instead of carbocation stability, first molecule stability should be attained. Okay. So this carbon is migrating to this. This is 1,2 alkyl shift. 1,2 alkyl shift. So the carbon directly attached to the methyl will get positive charge. So here it will be going to attach with this here. So final product will be this. Okay. Similar kind. This is even easy. So it's going to expand. So this is also going to give. So here carbocation and the final product will be same. Okay. Even for the 35, ring expansion happens up to 6 members. Okay. 6 member వచ్చే వరకు stable. So 6 members అయితే so carbocation will generate here. So Cl is going to attach here. This is going. I think in this I made a mistake. I'm sorry. Uh, so it is delocalizing. Okay. And ring expansion happens. So this is secondary carbocation. Again there is a possibility of hydrolysis. So it's going to give tertiary carbocation, which is most stable. So product will be this. Okay. Because I missed the possibility because if at all it is forming, it will be secondary. While only secondary is stable, there is a possibility of tertiary also. So you need to go with the tertiary. So this is most stable. Okay. The same thing. 6 member secondary, which is less stable. With the hydride transfer, it's going to become 6 member tertiary. So if it is attracted with bromine, simply if you want to give directly products, there is a possibility to give most substituted carbon. Okay. So directly attach the halogen to the most substituted carbon until unless there is a ring expansion not happens. Okay. Ring expansion లేకపోతే మీరు direct రాసేయాలి. Okay. Direct most substituted. For example, here you can write the most substituted carbon. Okay. Here, if this kind of is a little difficult. Okay. So they have carbocation stability difference. Okay. If this is the case, you can write directly. So write here. Okay. సో అన్నిటికీ పాసిబుల్ కాదు. ఎక్కడైతే రింగ్ ఎక్స్పాన్షన్ లేకుండా రీఅరేంజ్మెంట్ ఆల్కైల్ గ్రూప్ రీఅరేంజ్మెంట్ లేకుండా ఉంటే డైరెక్ట్ మోస్ట్ సబ్స్టిట్యూటెడ్ కార్బన్కి ఇచ్చేయాలి. ఓకే. నెక్స్ట్ వన్. So again there is a carbocation generation at tertiary. Okay. So here again ring expansion is going to happen. And this carbon which is next to the 2 methyl group. So this gets carbocation. Okay. Again here no hydrogens are there, but methyl group can transfer. So here is the positive charge. So among all these carbocation, this is the stable one. Okay. This is a stable one. So it's going to give product. And, okay. Next one. Once H plus added, this is what carbocation generated. So 1 to methyl shift is going to happen because this is a strain ring. 3-member ring is strain, so it's going to expand. Okay. So if it is hydrogen shift, okay, if it is hydrogen shift, it's going to give the same secondary carbocation. This will not happen. Okay. So this is the most stable one. Okay. So it's going to attack it by the beer to result the product. Okay. Next one, 38. H plus addition and carbocation generation is at most substituted carbon and is going to expand. Oh, it is going to give, okay, after ring expansion. So this carbon is migrating, so that carbocation will generate. Okay. So carbocation generation and the Cl minus attack. So resulting into the product. Okay. So these two are little different when compared to others. So let's see 40 first. So among olefin and acetylene, which is more nucleophilic, which can donate the electrons better? Triple bond and double bond. So ఒకసారి hybridization చూడండి. This is sp2, this is sp. So electronegativity దేనికి ఎక్కువ ఉంటుంది? sp. So electronegativity ఎక్కువ ఉంటే donation capacity ఏమైతే తగ్గుతుంది. Okay. So double bond is more nucleophilic. So it will be going to that. Okay. And carbocation will generate here and here. If it is triple bonded carbon adjacent, it will be withdraw, so it will not form here. So carbocation will be here. Yeah. So this will be the final product. Okay. Now for this one, once it gets attached with the H plus, it's going to give CH2 CH. Okay. Sorry. CH2 CH plus. Okay. So now if it is forming or attaching with the Cl minus, so it's going to give vinyl. Okay, vinyl chloride. So again if it is attached with the H plus, so here carbocation, here also carbocation. So this is most stable because of the mesomeric. యాక్చువల్గా ఇండక్టివ్ ఎఫెక్ట్ చూసుకుంటే ఇలా ఉంటుంది. సో మీజోమరిక్ ఎఫెక్ట్తోని ఇది మోస్ట్ స్టేబుల్. సో one more double bond is going to eliminate. So Cl next. Okay. So now one more Cl will attack. So product will be 1,1 dichloroethane. Okay, 1,1 dichloroethane. So 1,2 dichloroethane ఎందుకు ఫామ్ కాదు అనేది క్వశ్చన్ అన్నట్టు. ఓకే, బికాస్ its stability is going to direct by the mesomeric effect of the chlorine. Okay, so it's going to give 1,1 dichloroethane. Okay, so these all are practice questions for the Markovnikov. If any further questions available with you, you just practice and find out the major products. Okay, so any doubts from this? Alkynes? Any double bond can be considered as a nucleophile. Double bond, triple bond, ఏదన్నా పై బాండ్ న్యూక్లియోఫైల్ గా యాక్ట్ చేస్తుంది. సో మార్కోనికాఫ్, యాంటీ మార్కోనికాఫ్ ఈ రూల్స్ ఏవైతే ఉన్నాయో ఇవి సిమ్మెట్రికల్ అన్సిమెట్రికల్ మీద డిపెండ్ అయి ఉంటుంది. సో దిస్ is symmetrical. There is no Markovnikov rule for this. So that's why I just added carbocation and added chlorine. After this is unsymmetrical. Okay. ఫస్ట్ ప్రొడక్ట్ ఫామ్ అయినాక ఇది ఫామ్ అయింది. ఇప్పుడు అన్సిమెట్రికల్ కనుక ఇప్పుడు మార్కోనికాఫ్ రూల్ బేస్ చేసుకొని కార్బోకాటైన్ జనరేట్ చేసిన, అందులో స్టేబుల్ కార్బోకాటైన్ తీసుకున్న దానికి అడిషన్ చేసిన. అది ఆల్కైన్స్ కైనా ఆల్కిన్స్ కైనా దేనికైనా కానీ సేమ్. ఎనీథింగ్ ఎల్స్? సో ఇంకేమైనా డౌట్స్ ఉంటే గ్రూప్లో పెట్టండి. ఓకే, విల్ డిస్కస్ దట్ ఆల్సో. ఓకే.